talk about special right triangles. We're going to learn some rules about the triangles, and it'll make finding missing sides a lot easier if you understand the rules. We're going to just copy down the rules, the pictures of the triangles, and then we're going to do some examples to explain how they work, and I'll better explain it. The book's triangle looks a little differently than this. They probably have it looking like this. And not the orientation, that really doesn't matter. They probably have it looking like this, and then it's labeled S and 2S and S times square root of 3. They probably have it labeled like that. It makes a lot of sense why it would be labeled that way, because these are ratios. I just typically find that for many students, the S gets confusing, and so I just write it this way. It's just the way I've always learned it. So either way is good, and I'll try to make sure you understand what we're saying in both of them. So I'll pause now and you can finish copying this down. This is a 30, 60, 90 right triangle. There's a special relationship between the hypotenuse and the short leg, and there's a special relationship between the long leg and the short leg. I like these two rules written this way because it helps you to solve when you're looking for one of the sides, okay? And these rules match what we're saying up here. If S represents a short leg, right here, then the hypotenuse, the side opposite the 90-degree angle, this one here, is always going to be twice as long as S. And what I'm saying in this one is, if my short leg is 1, then my hypotenuse is going to be 2. It's going to be twice as long, okay? And the long leg is going to be square root of 3 times as long as the short leg. And so, if again, over here, if my short leg is 1, then my long leg is going to be square root of 3. 1 times square root of 3 is square root of 3, okay? But these two rules are probably, written this way, are probably going to be the most helpful for you to solve today's problem. I really like this lesson because it gives you the opportunity to look at a triangle, and if you identify that it's a 30, 60, 90, or what we're going to do in a minute, a 45, 45, 90, you can identify it's one of these two types of triangles, then you can find information about missing sides very, very easily. Sometimes just by looking at it, sometimes with a simple division, and you have what you need, okay? Again, we're going to do some examples that will hopefully help you make more sense of this. Let's move on to 45, 45, 90, and I'll pause while you copy that down. In a 45, 45, 90, remember the isosceles triangle rule. If the angles of a triangle, if two angles of a triangle are congruent, actually the converse of the isosceles triangle theorem, that means the sides opposite it has to be congruent. And so, in this case, I'm saying that both of these sides are 1, then the hypotenuse is going to be square root of 2. So in other words, the hypotenuse will always equal the square root of 2 times the length of the leg. Now again, the book's triangle is a little different. They probably have it looking like this. S, S, and S times square root of 2. And so probably their triangle looks more like that. But again, if you find that more helpful, go ahead and write that down. For me, it's just cleaner and simpler, again, in the way I've always used it and learned it probably was without the variables. But it is important that you understand that the legs are not always 1. And the short leg in the previous 30, 60, 90 triangle is not always 1. but the relationship between the short leg and the hypotenuse was always twice as long. And in this case, the relationship between the leg and the the hypotenuse is always going to be square root 2 times bigger. Okay? Square root 2 times bigger. So, anybody not done copying this down? Alright. Let's get into some examples. They can give you some pretty messy looking triangles. I'll pause for a minute while you copy the triangle. If we look at the triangle on the right, is that a special right triangle? Is that one of the two we just talked about?
Yeah.
Okay, what is it?
3069.
3069. They didn't give me a 60, did they? But they gave me the 90. They said this is perpendicular, which means that's 90, and that one's 30. So this one's got to be 60, right? And in this other triangle, since this is perpendicular, has to be 90. And since that's 45 here, this one here has to be 45. Okay? And so on the right, I have a 30, 60, 90 triangle. On the left, I have a 45, 45, 90. Now, if I go back to the one on the right, do I know any of those sides? No. So since I don't know what those sides are, I'm going to have to move to the one on the left. What's wrong?
Pencil.
So looking at the one on the left, the only thing I have is which side? 6 square root 2, but which side does that represent? The hypotenuse. And it's in which triangle? Okay, in which the rule was the hypotenuse is equal to, what's the rule? Square root of 2 times the leg. Okay? So in this case, what's the leg?
6.
Okay, let's write down what they have as the leg. R, okay, R is the leg,
So is X.
and so is X, that's correct. We'll solve for R first. And the hypotenuse is what? How long is the hypotenuse?
6 times the square
6
root.
square root of 2. So my point I was getting at, which will make this easy for you, I know many of you look at that and say, well, that's 6. The leg has to be 6. I heard many of you say that. And I agree, and this problem is that easy. But in some problems, it's not going to be that easy. So you need to make sure you understand what's happening here. That's why I'm doing this, what some of you might think is the long way. Okay? I'm going to substitute into my rule what is in the picture for the leg and for the hypotenuse. And so then I'm going to solve for R. What would I do square root of 2 to get rid of it? No. This is times, right? How do you undo that? Divide. So I'm going to divide both sides by square root of 2. And so those cancel. R is equal to, what happens to my square root of 2's on the left? They cancel. So I'm left with 6, which is what many of you said to begin with. Certainly wasn't arguing with you. You were right. And that's exactly what I like about these problems. Many times you can look at it and know the answer right away. You know what the other sides are. You know all the information. Okay? So if R is 6, what's X?
6.
They have to be congruent, right? 45, 45, 90, then the two legs have to be equal. So if R is 6, then X is 6. So now if we go back over here, I'm going to write this in here. Now I know which leg of my 30, 60, 90.
The short leg.
Short leg, that's correct. And again, many of you could look at this right now and know what S and what Y are. I'm going to write the rule out just to make sure that we can solve when it's not this simple. I'm going to abbreviate short leg with SL. Okay? Not SNL, just SL. What's the hypotenuse in this case? Do I know?
Y.
Well, it's Y. That's correct. And what's the short leg? Do I know that?
6.
6. And so how long is y? 12. Okay, then the long leg is going to equal square root of 3 times the short leg. And we know the short leg is 6. So the long leg, excuse me, if I write that, oops, the long leg, sorry, we actually know it has a letter. Oops. The long leg was
S.
S, thank you. And so S is equal to 6 square root of 3. Whenever you have a square root in your answer, you always want it second. Because what happens if you write it first, sometimes that other number slides underneath the radical sign a little bit, and so it looks like you have something else. Okay? So we kind of treat a radical like we would a variable. We always write the number that's not under the radical first, and then the radical sign. Okay? All right. Any questions on this problem? How I found each of these missing sides. Okay, moving on to the next example then. This is a good example for why we want to write the rule down and substitute in and do all those things. Okay, so what kind of triangle is it? 30, 60, 90. You're doing these examples with me, right, Sean? What, in the 30, 60, 90, what's one of my rules? Just state what the rule says.
Hypotenuse 2 times the short leg.
Okay, I'm going to abbreviate hypotenuse a little bit. Hypotenuse equals 2 times the short leg, right? What's the other rule?
Longer leg is square root of 3 times the short leg.
Okay, good. Now, do I know the hypotenuse? Do I know the short leg? No. Sometimes the picture's poorly drawn and it's not to scale. So how do I know for sure that X really is a short leg and not just a badly drawn picture? Go ahead, Hunter.
Because the angle that corresponds to it kind of is smaller.
What's he mean by corresponds?
That's across from.
There you go. And what's he mean by across from? What's that word we use?
Opposite.
Opposite. If the side is opposite the smallest angle, then remember last chapter we learned that it has to be the smallest side, right? And so X is opposite the 30-degree angle, so X is our short leg. We don't know what that is, do we? What's the long leg? 7. Okay? Now some of you may have a really sharp mind and you've done a lot of this and you can snap out the answer right away. Others probably need to write this down. How do I solve for X now?
Divide by
Divide by what? Square root of 3. Sorry, I didn't hear the square root. You know, unfortunately, they have this silly rule that says you cannot leave a radical sign in the denominator. And so you have to do what they say is rationalizing the denominator. And so to rationalize the denominator with a single term in the bottom, just a single square root of 3, we multiply top and bottom by that denominator. Okay? Multiply top and bottom by that denominator. So on top I get 7 square root of 3. On the bottom I get, what is square root of 3 times square root of 3? Square root of 9, which is 3. Do you see see when I multiply a radical by itself, the radical sign disappears. Okay? Now some people make the mistake of thinking, oh, I can cancel my 3's now. But you cannot. Okay? This is 3. This is square root of 3. Whoops. Sure got away. This is square root of 3. They are not the same number. Okay? If you believe they are the same number, then please loan me $3 today, and I'll return the square root of $3 to you tomorrow. Okay? In fact, I'll throw in 30 cents interest. They're not the same number, are they?
No.
How big is square root of 3?
1.
0.7.
1.7? Okay, so it'd be like $1.70. If I throw in 30 cents extra, we have about $2. So you give me 3 today and I'll return 2 tomorrow. We'll be good, even? Yeah, not so good, is it? So, the point is they're not the same. Can't cancel them. Although some people just see the 3 and think, oh, let's reduce that. But you can't. So fight that urge. Do not try to reduce the square root of anything with anything that's not in the square root. Okay? And so this is how we leave our answer. This is simplest radical form. So that's x. What did x represent?
The short leg.
The short leg. So now we come back up here. We now know what the short leg was. 7 square root of 3 over 3. That's going to equal the hypotenuse, which was y. Now remember, 2 is really over 1, right?
Yeah.
2 over 1 is still 2, correct? And so when you multiply fractions, you multiply straight across the top, unless you can simplify. Does 2 and 3 have any common factors other than 1? No. So straight across the top. 2 times 7 is 14 times square root of 3. And on the bottom, 1 times 3 is 3. So that is the length of my hypotenuse. Okay? Not quite as easy just to look at and know the answer, is it? But if you have the rule, if you apply the rule, substitute in and solve, it's just a simple one-step equation, right? Right here is a simple one-step equation. And then you have to rationalize the denominator here to get an answer that's in simplest radical form. Okay? Moving on. This is a great question. Okay, in fact, I'm going to need that on there. They might even ask you on this problem to find the area. So let's do that. Let's find the area. What's the formula for area of a trapezoid? Hunter?
1/2 height, parentheses, base 1 plus base 2.
Nice. You'll be thankful that it's a group test if Hunter's in your group and he can remember things like that for you. Alright? And I'm telling you right away, this is going to be a group test for many reasons. So what I would do is make sure that in your group you each agree at least who's going to remember all these formulas, because I'm not going to give them to you. Okay? There's quite a few, and some of you may already know them all. But still hold someone else accountable. Okay? Don't let someone in your group skate by and not know anything. Sorry. Caleb, you got me in trouble. All right. You know what I'm saying, though. I want everyone in your group to be active and take part of the test, and it's good for them, too. We all need to feel like we have a value. All right? How long is this side right here?
That's what it was.
3. You know what? So many people tell me that that's 3.
It's not.
It's not though. But so many people tell me that's 3. I'm telling you right now. On the test, someone will be saying that that's 3. It's not 3. Why is it not 3? The angles are different. It's a badly drawn picture, isn't it? It is not at all to scale, is it? Okay? This little 45 down here is saying that angle's 45, and if I got my protractor out, that angle's definitely not 45. Okay? So, badly drawn picture. That's why it's very important that you, just set on my desk. It's very important that you look at the picture and look at the information they give you. Well, this is 30 degrees. Okay? And this is the what side of that 30-degree angle? That triangle, I mean. What is it? It's a short leg?
That's a long one.
That is the long leg, isn't it?
Yeah.
Badly drawn picture, isn't it? And so this, the height of this picture is the long leg, or is the short leg, isn't it? So what's the relationship between the long leg and the short leg? Long leg equals square root of 3 times the short leg. And what's the short leg in this picture?
3.
You're still falling for it.
H.
Remember the short leg's opposite the small angle, right?
Don't know.
So it's H. And what's the long leg? 3. And so how do I find the hypotenuse?
Square root of 3.
I'm sorry, I didn't mean to say hypotenuse. I meant the height, H. Divide by square root of 3, right? So if I multiply top and bottom by square root of 3, then I can rationalize my denominator, correct? So on top I get 3 square root of 3, and on the bottom I get 3. Does anything reduce? Yeah, what?
The 3.
The 3's. So that means H is equal to
1.
the square root of 3. So H is the square root of 3. H is the short leg. Okay? So that means over here, this is still square root of 3, isn't it? These are equal. They're both perpendiculars. Okay? They're equal. And so, how long is this little piece now?
3.
Still not 3. What kind of triangle is this?
45, 45.
45, 45, 90. Is this a leg? Is this a leg?
Yeah.
What's true about our legs?
Square root of 3.
They're equal, right? So how long is this little side?
Square root of 3.
Square root of 3. And what's in the middle?
7.
7. So how long is my bottom base?
13.
10 square root of 3.
10 plus the square root of 3. So this side, let me move this down a little bit. This is messy, isn't it?
Look at something else.
7 plus 3 plus square root of 3. That's 10 plus square root of 3. Okay? That's one base. And so the top base was 7, and the bottom was 10 plus square root of 3. And my height I found to be square root of 3. Okay? What is 10 plus 7? 17. Okay? And so if I distribute this, I get 17 square root of 3 divided by 2. And I get, what's square root of 3 times square root of 3? 3. divided by 2. And so my area is equal to this. Okay? Now, I don't think you have any that are truly quite that messy. The intent of that question, the reason I want to go through it with you, is for you to understand that you cannot look at a picture and make assumptions about how long sides are. You have to go by what they gave you. Okay? And in this picture, this height and this side are equal, even though they absolutely don't look equal. They have to be, because that's a 45 and that's a 90. Okay? And over here, if this is 30, then this is the short leg, and this is the long leg. Alright? You have to use that information then. You have to use that information to find your area. Okay? Alright. I thought that was the last one. Last little bit here. Today we're doing lesson 7-3, 3 to 39 by 3s, and the checkpoint quiz. Again, we'll be giving you a grade tomorrow on this, so get it done. If you're not getting these done, you're losing big points. Get it done.